Let's talk about scales. There are four scales that we'll mention here to be complete as part of your chapter. But really, the one that we'll focus on throughout the semester is the ratio scale. But let's cover them all just quickly. A nominal scale is a set of categories that have different names. Measurements on a nominal scale label and categorize observations, but there's no quantitative distinction between them. Even if those names are numbers, if you will. For instance, here's the number of a classroom, and you'll notice this is from, I believe, Oregon State. And you'll see that it not only has the number, of course, but Braille. We have Braille on our numbers here in McKibben. But the number doesn't signify anything, just like your social security number or your zip code, etc. So I couldn't say, gosh, room 270 at this campus building in Oregon is twice as good as room 135. And I can't say that the zip code of 90210 is many, many times better than 01100, I think it is, in Manhattan, the richest zip code in the country. So they're just, they're names. Now, of course, what else is on a nominal scale are things that actually are names and not numbers. The names of religions, the names of parties, like Democrat and Republican and Independent and, the Reform Party, etc. And the names of states or last names, etc. All of those things just merely signify. The only thing that might be a tad confusing is a number. Of course, the number often just signifies the floor that something's on, and then we have to give it a unique number to distinguish it from something else. But just like your social security number, my social security number is totally unique, as is yours, in order to distinguish from other people. An ordinal scale is a little different. We have a set of categories that are organized into an ordered sequence, and the measurements on an ordinal scale, they rank observations, but you cannot see the difference between them. For instance, can I tell the difference between an XL t-shirt and a large? There's no suggestion there about volume. I might assume that the volume of the large t-shirt is greater than the medium, and is in turn less than the extra large. And of course, the small has the least volume, but it doesn't give any indication about how many inches, cubic inches, I suppose, that the person's torso that that would fit in there. And by the same token, what about small, medium, and large drinks at a fast food place? Now, strictly speaking, they may have the ounces listed somewhere, but really they don't get into that. Here's another one. Most valuable player in a sports league. Kobe Bryant, the late Kobe Bryant, won a few most valuable players. But did we know the difference in magnitude between him and the second place player and the difference between second and third? No. We knew their rank, and Kobe was at the top, but we didn't know the difference between him and someone else. Academy Award winners. Someone will win for Best Actor or Best Actress next spring, and we'll be able to tell the difference between the person that was rated the best and he or she who may have come in second best. That's a tough one. So those are the vexing parts of an ordinal scale, is I can't tell magnitude. An interval scale will allow that. So, for instance, on Fahrenheit temperature, which we can relate to best here in the USA, generally speaking, it is the case that the difference in magnitude, say between 20 and 40 degrees, is roughly the same as between 40 and 60. But there's something lacking in an interval scale that exists in a ratio scale. And this is really kind of an absurd thing to say. Can I say that 40 degrees Fahrenheit is twice as warm as 20? Well, no. The reason I can't say that about an interval scale of Fahrenheit temperature is because 0 doesn't represent the absence of temperature. It doesn't work that way. It can be negative. We can go below 20, as it often happens up in the north central states and northeastern states here in the United States, and of course Canada. So because 0 is arbitrary here, I do not make statements such as twice as hot or half as hot, etc. So I can't say 40 is half as warm as 80 degrees. Doesn't work that way. In order for us to do that, we have to go up to a ratio scale. The difference between an interval scale and a ratio scale is merely one tiny thing, is that the ratio scale has a meaningful zero. Each of them have meaningful intervals. So 20 degrees Fahrenheit, the difference between 20 and 40 is roughly the same as the difference between 40 and 60. But with the ratio scale, the zero is actually meaningful. It quantifies a lack of something. Is money on a ratio scale? Yes. Is $5 half as much as $10? Yes. Is a half a quart half as much as a whole quart? Yes. Is 32 miles per hour twice as fast as 16 miles per hour? Yes. Because 0 miles per hour makes sense. $0 and 0 pennies makes sense. Though that's possible. And by the same token, 0 parts of a quart, whatever the heck that might be, in some milliliters, that also makes sense. So that's what makes something on a ratio scale is the real zero. It actually makes sense and has some real meaning to it. So there's a tiny difference between an interval and a ratio scale, and that's it, that real zero. I will say this, this is the only time that we'll visit this material on scales. For the most part, we'll just assume that everything that we're speaking of in the future is on a ratio scale.